Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem, the rotten orange from the SDE sheet. So what does the problem state? The problem states you'll be given a M cross N grid where the 0 represents an empty cell and the 1 represents a fresh orange, okay, and the 2 represents a rotten orange. So 1 for fresh and 2 for rotten. Correct. So every minute any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. What does this mean? Like if there is a fresh orange and on any of its four direction, if it finds a rotten piece, okay, this guy will also become rotten. Any of the four direction, if it finds a rotten piece, this guy will become a rotten orange. Okay, so that's what the question is all about. Now you need to return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So for an example, this is the initial grid state. So as you can see in the minute 0, you have a rotten orange, right? And these are fresh oranges. And these are empty cells. So in the minute 1, what happens is, this orange, which is a rotten orange, will start rottening the adjacent oranges. So this one and this one gets rotten. Now in the minute 2, what happens is, these guys have the adjacent as these and these. This guy has this and this. So it will rotten this and it will rotten this. As you can see, it has been rotten. And the next minute, what will happen is, this guy has this one as the adjacent and these guy have these ones. So this guy will be rotten. And in the next minute, this guy will end up rottening this. Hence this is rotten. So I can see at the minute 4, after this I don't have any orange that is still fresh. Hence the answer will be 4, because that is the minimum time that you will at least require to have all the oranges rotten. So let's check out the example 2. It says this one is a rotten orange. Okay, so can I say this will be minute 0's configuration? So what will be the minute 1's configuration? So the minute 1 will make this guy as rotten. Perfect. That will be minute 1. What will be the minute 2's configuration? This guy will make this guy rotten and this guy rotten. That will be minute 2. What will be the minute 3? The minute 3 will be making this guy rotten. What will be the minute 4? Will make this guy rotten. So can I say after 4 minutes, you don't have anything else to be made rotten, right? And you're still left off with this guy, which could not be rotten because it was diagonally 4 directions. This. So you could not rotten this guy. Hence, you have to print -1, because rotting only happens in 4 directions. That is the reason you could not rotten it. So if you can, you have to return the minimal, and if you cannot, you have to return -1. That is what the question is stating.
So अभी इंटरव्यूज के बारे में बात कर ही रहे हैं, तो लिंक्डइन के जो टॉप 10 स्टार्टअप्स है या फिर जो इंडिया के 5 यूनिकॉर्न कंपनीज है, कंपनीज लाइक अपग्रेड, रेजरपे, अर्बन कंपनी, क्रेड, येलो मैसेंजर, 1NG, डिजिट इंश्योरेंस, ये सारे कंपनीज में यार सबको काम करने का मन करता है कि नहीं? बट ये सारी कंपनी जनरली जो हायरिंग करती है दैट इज फ्रॉम टायर 1 या फिर IIMs हो गए या फिर IITs हो गए, इधर से जाके हायर करती है. सो वाया ऑफ कैंपस आप ये सब स्टार्टअप्स पे कैसे काम कर सकते हो? तो यहाँ काम करने के लिए आपको टेस्ट देने पड़ेंगे. सो रेलेवल एक प्लेटफॉर्म है जहाँ पे आप टेस्ट दे सकते हो, एंड आप टेस्ट दोगे तो आपको एक रेलेवल स्कोर मिलेगा, एंड उस स्कोर से लेके आप ये सारे कंपनीज उनके प्लेटफॉर्म पे है तो आप उधर इजीली अप्लाई कर सकते हो. एंड एक बार आपका प्रोफाइल शॉर्टलिस्ट हो गया, उसके बाद आपको इंटरव्यू कॉल आ जाएगा, एंड इंटरव्यू होने के बाद अगर आप क्लियर करते हो तो आपको ये सारे इंडिया के स्टार्टअप्स में जॉब करने का मौका मिल सकता है. सो हाउ डू अपीयर फॉर दीज टेस्ट? So in order to appear for these tests, you have to go to relevant.com and उधर जाके आपको register करना है. So the registration charges are 1,999 and if you want to get an exclusive 10% discount, you can use the coupon code take you forward. So आप जाके register कर लो. Once you have registered, you can easily book your slots, and according to your slots, you can give the entire test. So once you have given the test, you will get a test score, and with the help of that, you can definitely apply on this. And you can also create a profile which looks something like this. So guys, I'll be leaving all the links in the description. Please make sure you do check it out.
So let's take this 4x4 matrix, okay, and over here as you can see, this is one of the rotten oranges and this is one of the rotten oranges, and I need you to figure out the minimal time. So in order to do that, we have to use something like a breadth first search technique. If you do not know this, nothing to worry about. So first thing, what you will do is, you will start counting what is the number of oranges that you are currently having. Now the first thing that you need to do is just simply count how many like non-empty cells do you have. So can I say as of now the non-empty cells that I have is 1, 2, 3, 4 and over here 4. So the non-empty cells as of now is 8. So make sure you just keep a count of it. Okay. And what we will initially do is we will take a queue data structure. That is a mandatory stuff in BFS. You always take a queue data structure. Okay, now in this queue data structure what you'll store is I comma j, where I corresponds to this row number and j corresponds to the column number. Okay, and initially just make sure whichever are the rotten oranges, you store them into your queue. So 0 comma 0 is a rotten orange, 0 comma 3 is a rotten orange. So just make sure that you store them into your queue data structure. So how does BFS works? BFS generally has something to start off with. So you have the rotten oranges to start off with. Okay. So now what you will do is you will just make sure that at the first iteration you do work on the 0, 0 and 0, 3. So initially you will do something on 0, 0 and you'll do something on 0, 3. So that is what you will try to do on the first iteration of BFS. Now what will you do on 0, 0? You'll try to go in all the 4 directions. Okay, try to go in all the 4 directions from 0, 0 because the question stated 4 directions. Now from 0, 0, can you go to top? Obviously there doesn't exist just top. Can you go to the left? Obviously not. Can you go to the right? The right is an empty cell. So can you go to the right? No, you cannot go. So you will not go over there. Okay. Can you go to the down? So you know that you can definitely go to the down. So when you go to the down, what is the index? That's 1 comma 0. Okay, so what you will do is you will call it as a rotten now. Okay, and you'll take this 1 comma 0 and you'll put it into your queue data structure. Perfect. So this is done for this particular 0 comma 0. Similarly you will do for 0 comma 3. Does it have a top? No. Does it have a right? No. Does it have a left? It does have a left, but that's an empty cell. Does it have a bottom? Yes, it does have, which is 1 comma 3. So again, please make sure you mark it as rotten, and at the same time you take this 1 comma 3 and you put it into your queue data structure. So once you have made sure all the 4 directions of 0 comma 0 as well as 0 comma 3 has been marked, so your next step should be to end this iteration of the queue. And before ending this, probably you can keep a variable of minutes or days because we were requiring minutes. Okay, so let's keep it as days or minutes, whatever you can keep it. So you will check, does the queue have any other oranges? Now if there are two different oranges that came in as rotten now, that means the previous guy, that is 0 comma 0 and 0 comma 3 indeed marked someone as rotten. That is why as of now, because these 0 comma 3 0 comma 0 were removed and now we have something in our queue. So if we have something in our queue, that means these guys indeed marked someone as rotten. So can I say it took them 1 day? So I'll just increase the day to 1. So once you've done this, it's the next step. Again take 1 comma 0 and 1 comma 3. So 1 comma 0 will be taken, 1 comma 3 will be taken. Remember this. Again do the same step. So BFS means take these guys and do these steps. So you know it will have a top, a right, a bottom, a down. Perfect. So on the top of 1 comma 0 there is already a rotten orange. So there is no need to again go and rotten it. On the right of 1 0 it's an empty cell. On the left of 1 0 it's an empty cell. But at the bottom you do have a 2 comma 0, right? So you need to rotten it and you need to put it into your queue data structure. Perfect. So I've made sure that this is done. Next 1 comma 3. Again at the top you already have a rotten. At the right you don't have anything. On the left of 1 comma 3 you have an empty cell. On the bottom you have a 2 comma 3, right? So what you'll do is you'll put in 2 comma 3. So can I say these two guys made some guys rotten. That is why the queue is still having 2 elements. Can I say if they made them rotten, it will take 1 more day. It will take 1 more day And remember, they will make it in adjacent. Like the moment this blue makes this guy, it will take 1 day. The moment this blue makes this guy, that will be on the same day itself, because they can do it on the same day. So I'll make sure they do it. So once they have done it, it's time to again do the next iteration of BFS. Again, take whatever is at the Q. So it might be 2 elements, it might be 3 elements, just take it. So I've taken 2 comma 3, and I've also taken 2 comma 0 at the same time. Okay, so 2 comma 3, as I know, has a top, has a right, has a bottom, has a left. So does it have a 2 comma 3 is this? Does it have a top? It's already rotten. No need to take it. This is an empty cell. This doesn't exist. The bottom cell is 3 comma 3, which does exist. So make sure you take 3 comma 3. Yes, just do make sure you take 3 comma 3. Perfect. What about 2 comma 0? 2 comma 0 doesn't have a top, which is already rotten. This guy has a left, which doesn't exist. This guy has a right, which is 2 comma 1. So just make sure you take 2 comma 1. And it doesn't have a bottom because that's empty. So can I again say you ended up rotting these guys? Indeed you did. So I can say I've taken another elements, like there are new elements into the queue. So can I say these guys 2 comma 3 and 2 comma 0 ended up rotting some more elements, hence the days will increase to 3. Now again, the next iteration of BFS, it's a 2 comma 1. So just take 2 comma 1, and it's a 3 comma 3. So let's take 3 comma 3. So on 2 comma 1, that's this guy. It doesn't have a top, it doesn't have a right, it doesn't have a bottom. On the left, it's already rotten. So on all the 4 directions, I did not find anyone. Yes, I did not find anyone. On 3 comma 3, I have this. On the top, there is already rotten. On the left, it's rotten. On the bottom, nothing. On the right, nothing. So can I say again, on the 4 directions, I did not find anyone. Indeed, hence do I insert anything, like these guys did not rotten anyone. And at the end of the day, I can say it's over for these guys, and the queue ended up being empty this time. So whenever the queue is empty, it means these guys did not rotten up anyone, hence the days will not be increased anymore. And at the next iteration, I see the queue size is indeed empty. So I can say let's end up our iteration. And at the end, remember this. Whatever is the number of elements that you always inserted into the queue, just keep a count. So that was 2, that was 2, that was 2, that was 2. So in total, the number of elements that you inserted into the queue was 8, and your number of oranges that was given to you was 8 in total. So can I say, if these guys were inserted into the queue, these guys were indeed rotten. So I am very much sure that I ended up rotting the total amount of oranges that were existing in the 4x4 grid. And if that was the case, can I say the number of days that I took was 3. Had this 8 been not equal to the count of 8, then I could have said, yes, then I could have said ki days was not 3 and days was -1. It is not possible. But over here, since the count of rotting of oranges is equivalent to the count of oranges given to us, I can say the days taken up is indeed 3. I'll come to the time complexity and space complexity afterwards when I discuss the code. So let's discuss the C++ code. So you're given a 2D vector, okay, and initially what I do is, if that vector is given as an empty vector, I'll return 0, saying no, the minimum number of minutes is 0, and I've computed m, I've computed n, okay, and I've taken variables like days, which will count the minimum number of days. Total is the number of oranges given to us, and count will keep a track of how many have been rotted by me. Okay, how many have been rotted by me. Right after this, I declare a queue of a pair. Okay, we'll declare a queue of pair, and I'll just iterate on the 2D matrix, and I'll just make sure how many oranges are non-zero, non-empty, and I'll also make sure how many are rotten. So initially, as you did in the queue, if you remember, you just pushed all the rotten oranges. So I'll push it over here. Now why have I taken this? It's a very simple stuff. I'll tell you afterwards. Okay, just make sure that you write this. I'll tell you why afterwards. So as you know, the BFS iteration went in till it wasn't empty. So the BFS, the queue's name is rotten. So keep on iterating till the rotten is non-empty. Okay. The first thing that you'll do is, if you remember, initially you had a 0, 0 as well as a 0, 3, and I took up a 0, 0, and then I took up a 0, 3, correct? And then I iterated for all the 4 directions, if you remember. That is what I've done. I made sure what is the size of this. So the size as of now will come up to be 2. Okay. And now what I've done is, I've also kept a count of how many are rotten. If you remember, we at the end of the day we counted 2 plus 2 plus 2 plus 2. So that is what I've done over here. Count plus equal to k. Now I've started iterating. Since I know the count as of now is 2 rotten oranges, so I just started counting. And I initially took the first, which is the x coordinate, and the second, which is the y coordinate. Okay, then I just took it off. So first time I'll get 0, 0 on this while loop. Next time I'll get 0, 3 on this while loop. So it's a while loop which runs on the queue elements. Perfect. Now what about these 4? You know, for 0, 0 we consider an upward, a rightward, a downward, a leftward. These are the directions that we considered. Now can I say 0, 1? What does that mean? Can I say 0, 1 means plus 0 plus 1 is this direction, the rightward direction. Indeed. 0, minus 1, what is this direction? That's nothing but the leftward direction, 0, minus 1, because the coordinate has to be added plus 0 and has to be subtracted minus 1. What about 1, 0? Can I say that's the downward direction where you say plus 1 and plus 0 onto the coordinate? And can I say minus 1 minus 0 is the upward direction, which is minus 1 minus 0 on subtraction. So if I just add, will I get my new x and new y, that is the upward or leftward or downward or rightward. So instead of writing the 4 directions individually, I just made sure I use a dx as well as dy. Okay, now this if statement checks if these guys are valid, like are these inside my boundary. Okay, and it also checks if previously it is not a fresh, like if it's a rotten orange. Okay, so if it's nothing, like if it's not an orange, if it's like an empty cell, or if it's a rotten orange, I'll just continue, I'll not put it into the queue. But if it is not, then I make sure I mark it as rotten and I push it into my queue, right? The queue, I push it into the queue. So that is what I will do for 0, 0 as well as 0, 3. That's why the while loop runs for k times. Got it? So once this entire while loop ends, can I say if I had rotten someone, the queue will contain something, and if it contains, I'll just increase day plus plus. So I'll keep on performing this while loop till it exists, right? Till rotten oranges does exist. Once that is done, I can easily compare the total number of initial to the current count that is in the queue. And if they are equal, that means I have ended up rotting everyone, and I can easily return the days. And if I was not able to, I can return -1 stating I was not able to rotten it. Perfect. Can I say the time complexity will be nothing but bgo of n crossed n, if n crossed n is the cell dimensions. Why? Because what are you doing in your queue? At max you're taking all oranges. So at the worst case, what might happen? At the worst case, if you imagine what might happen, there is a rotten orange here and these are the oranges, right? So you'll end up putting this guy into the queue, you'll end up putting this guy into the queue, 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 this guy, this guy, this guy, this guy. So at the worst case, the BFS will run for n cross n, because that is the maximum number of cells that can be into the queue. Perfect. As well as into 4, because for every cell you are taking upward, rightward, downward and leftward. So for every cell you're also taking a 4 loop. So it's a n cross n into 4. Whatever the space complexity, I can say the worst space complexity can be bgo of n cross n, because if initially you're given a state where all the oranges are rotten, just imagine all the oranges are rotten, so you end up pushing everything into the queue at the initial. So the maximum size the queue can take is bgo of n cross n. So initially you're given a 2D grid, okay, and what you'll do is if the grid is null or if the length of the grid is 0, you'll return a 0, or else you'll find the rows numbers and the column numbers by doing a grid dot length or grid of 0 dot length. And I've done is I've declared an pair, like an int array of q. I'll be storing pairs. As you saw, we were storing pairs, okay. So the q has been declared where we'll be storing 2 elements. Now what are you doing? You're saying how many initial oranges are there. So I just make sure ki I count all the oranges, like it's not count fresh, like it's all the oranges that are non-zero, will be counted. So I iterate in the 2D matrix and I make sure whatever is rotten, that is initially pushed. So in the example that we took, if you remember, we pushed in 0 and 0, 3. So all the rotten oranges will be pushed by this example. And if you remember, the count was taken as 8 initially. So this is where the count will happen, because if it's non-zero, please make sure you count the total number of oranges, okay. And if by chance, if the number of count, like the number of oranges is 0, so I know I'll not require any time, so I can definitely return a 0, or else I'll keep couple of variables. The first variable is count mean, which is again 0, and the count is also kept as 0. So if you remember, at the end of the day, we ended up counting like 2 plus 2 plus 2 plus 2, and we got total of 8 oranges that were rotten. So that 8 will be stored in this count, okay. And what about count mean? Count mean will count the number of days, the minimal days, which is initially 0, okay. I hope you have understood this. So what was the first step that you did in your BFS? You took the 0, 0, if you remember, you took the 0, 3, correct? So that is what I've done. I made sure I get the size, okay, and I iterate on the queue. And every time what I'm doing is I'm first taking 0, 0, that is what the first iteration will do on I, and the next time I'll take 0, 3. So this for loop will make sure I take up first 0, 0, then 0, 3, okay. Now what am I doing on every coordinate? Now I know one thing, every coordinate will have an upward, will have a rightward, will have a downward, will have a leftward, and I need to check for oranges in all the 4 directions. So can I say, if I take this direction, that's nothing but plus of 0 plus of 1, like on the coordinates, that is what I've written over here, dx. Can I say this is nothing but, like this is nothing but 0 comma minus 1 on the coordinates. If you do a 0 on this coordinate and if you subtract the column by minus 1, you will reach the leftward, correct? Now can I say 1 comma 0 means if you just keep on adding a 1 to the row and you do not add anything to 0, you will reach the downward. And can I say if you subtract 1 and you do not do anything to the column, you will reach the upward. So in this direction, in this way, you can reach all the 4 directions. So what I've done is I've run a loop which is running for 4 times, okay. I'm just doing the x coordinate, like if I'm at 0, 0, I first get this coordinate, then this, then this, then this, and in order to get these coordinates, I'm just adding dx of j and dy of j, okay. So I've got x and I've got y. Now what am I checking? If these are inside my boundary. If it's not, I can just do a continue. Or what is the other thing that I'm checking? Is that an empty grid? If that's an empty grid, I don't have to rotten it. Or if it's already rotten, I don't have to. If any of these cases exist, I'll not put it into the queue and I'll go back. Or else, if you remember, for 0, 0, the downward guy, that's 1, 0, was indeed rotten. So if that's rotten, you'll just go and mark it as rotten and I'll put it into the queue. So I'll just put in 1, 0 into the queue for this guy, and for this guy, if you remember, 1, 3 was put in into the queue. So I'll just put in. So once these guys are put in, right? Once these guys are put in. So can I say once the entire for loop is over, that means I've iterated for this and this. And if I find the queue size to be non-empty, can I say if the queue is non-empty, which means it has rotten oranges. So I can easily count the days or the minimum days to make it as 1. And this will keep on moving 2 to 3. And ultimately, can I say the initial count fresh, which was 8 in our case, and we can keep on counting 2, 2, 2. That will be easily done by this step, count plus equal to size. Every time you start, you get whatever is the number of rotten oranges left. And at the end of the day, if initial equal to the final, then can I say I've rotted everyone and I can return the count min? And if it is not, I'll say I cannot and I'll return a -1. Okay. What about the time complexity? Can I say the time complexity will be big O of n cross 4? Why? Because at max, how many cells do you have in an n cross n matrix? Like assuming n and n is the length of the 2D matrix. How many cells will you have at a maximum? It will be like at max driver, we will have n cross n cells. So don't you think the queue at worst case will have n cross n cells? Because so I can say if at the worst case, if I'm given something like an orange, something like this, so this will rot this, then this guy will rot this, then this guy will rot similar something like this. So at the end of the day, I'll end up visiting this 4 cells, which is n cross n cells, and for every cell, I'm going to try out 4 directions. So for every cell, I try out 4 directions. So n cross 4 is the time complexity. What about the space complexity? That's big O of n cross n, which the queue might take. Let's assume you're initially given a matrix which has all the oranges rotten. Then initially you will end up putting all the rotten oranges into your queue. So initially the queue will have all the cells, which is n cross n. So that's the time complexity as well as the space complexity about this BFS solution. So guys, I hope you have understood the entire explanation as well as the C++ and the Java code. Just in case you did, please make sure you like this video, and if you're new to our channel, do consider subscribing. With this, bye bye, take care, stay home, stay safe.